Hi everybody, hope you are doing well. And we continue topics related to the chemical reaction. And this is the chemical calculations. We need first to know what is the mole. The mole is simply the amount of substance that result from a chemical or enter a chemical reaction. When we take the chemical reaction such as H2 plus Cl2, which gave us 2HCl, okay? So hydrogen and chloride and chlorine are the reactant. Here we have one H2, which is 1 mole of H2, and one Cl2, which is 1 mole of Cl2. And the resultant or the products are 2HCl, which means 2 moles of HCl. So the mole is the amount of substance that enter or resultant from a reaction. Okay. And we have another definition, which is the molar mass. This is the mass of 1 mole of a substance. So when H2 enters the reaction, so one mole of H2 has a molar mass, and it is expressed in grams. The atomic mass is the mass of only one atom. You know, atom is the simplest unit, and the atomic mass is the mass of one atom, and its unit is the atomic mass unit, or A, mu, or U, or mu. Okay, so we have a difference between the atomic mass and the molar mass. The molar mass is the mass of 1 mole and is expressed in grams, while atomic mass is the mass of the one atom, which is expressed in U or A mu. In reality, we know that the atomic mass is the number, just to remind you, if you remember the structure of the atom. If this is an atom, a symbol of the atom, we have here if we have an atom X, we have a number here, which is the atomic number, and this atomic number equal to the number of protons or the number of electrons. And we have here the atomic mass, which is equal to the number of protons and the number of neutrons, which is the mass of the nucleus. And if you remember, the mass of the nucleus is the mass of the atom, because the mass of the electrons are negligible. They are very, very tiny to consider them. So this is the atomic mass that exists in any atom. If you look at the periodic table, you found it down here. Okay, this is the atomic mass, and this is the mass of only one atom. But when we make a chemical, when we make a chemical reaction, we couldn't take one atom and one atom, but there is an international system unit, which is the mole, that is used to measure the amount of masses enter the reaction. So when we see in the reaction one of any substance, means 1 mole of this substance. This 1 mole has a mass called the molar mass, and this mass is expressed in grams. So it's easy to quantify and to know what are the masses, what are the weights that we use in the chemical reaction. Because the atom is very tiny, to depend on it for measuring the amount of this substance to enter the chemical reaction. So the molar mass has the same number of the atomic mass of an atom, but in grams. For example, sodium has an atomic number of 11, and the atomic mass of 23. So this 23 is the mass of one sodium atom, okay? And its unit is U or AMU. The molar mass of 1 mole of sodium is 23 grams. 23 grams. For oxygen, oxygen has an atomic number of 8 and a mass number or atomic mass of 16. So the atomic mass is 16 AMU or U. This is a very small weight, which is the weight of one atom of oxygen. And the molar mass of oxygen is 16 gram. So 1 mole of oxygen means 16 grams of oxygen. So every 16 grams of oxygen equals to 1 mole of oxygen. Okay? So 1 mole of sodium chloride of sodium is 23 grams. Okay? For hydrogen, hydrogen is 1 and 1. So the atomic mass of hydrogen is 1 AMU, while the mole of hydrogen is 1 gram. Okay? Let's have it in more realistic example. If we have the equation that I wrote before, H2 plus Cl2 have 2HCl. Okay, 2HCl. So 1 mole of H2. Okay, when we make this equation in that way, so it means that every 1 mole of H2 reacts with 1 mole of Cl2 gives 2 moles of HCl. So the 1 mole of H2 is H2 is 2 hydrogen. And the mass of 1 mole of hydrogen is 1. Okay, so 2 grams every 2 grams. So because the atomic mass, the number that represents the atomic mass is the same number that represents the mole of this substance, of this atom. But the molar mass is in grams. So it means that hydrogen, 1 mole of hydrogen is 1 gram. So 2 hydrogens, 2 hydrogen atoms, which means 2 grams every 2 grams of hydrogen. This is 1 mole of Cl2. Cl2 is 2 Cl atoms, and the atomic mass of Cl is 35.5. So 2 Cl atoms, the molar mass or the molecular mass is 35.5 times 2, which is 71. This equation means that every 2 grams of hydrogen reacts with 71 grams of chlorine atoms. Remember, this is the mass of the atom. To give at the end these grams of HCl. Okay, so simply the mole is the amount of substance that enter or result from a chemical reaction. A molar mass is the mass of 1 mole of substance. Okay, which is expressed in grams. The mass, the molar mass of an atom, the same number of the atomic mass, but in grams. Okay? The molecular mass is the sum of the atomic masses of the atom forming the molecule. If we have a molecule like H2, it's a molecule, so the atomic mass of this H2 is the summation of the atomic masses of the atoms of this molecule. So for H2, the atomic mass of H is 1, so H2, the atomic mass is 2. 1 plus 1. For example, to calculate the mass of a molecule, calculate the molar mass of a molecule. This is the molar mass. Remember, molar comes from mole, so it's the mass of 1 mole. So how many grams are in 1 mole of hydrogen of water? So we have to know the atoms that form water. In water, we have 2 H, so 2 hydrogen atom and 1 oxygen atom. Okay, and then for the hydrogen, we have 2 multiplied by the number of grams in 1 mole of hydrogen, which is the same as the number of atomic mass, which is 1, added to the grams of 1 oxygen, which is 1 times 16. Again, the molar mass has the same number as the atomic mass, but in grams. So this will be 2 plus 16 will be 18 grams. So the molar mass of 1 mole of water is 18 grams. This table shows the elements, some of the elements with their atomic masses. The atomic masses, we can see it in the periodic table. You can see the atomic mass in the periodic table. Okay, and the atomic mass is for each atom, The molar mass is the mass of 1 mole, which is expressed in gram. As you can see, they are the same. Hydrogen is 1 unit, the atomic mass, and the molar mass is 1 gram. For example, nitrogen is 14, the atomic mass of nitrogen is 14, and the molar mass is 14 gram. Okay, and so on. The molecules of these atoms, of these elements, if exist, like for example, hydrogen exists in nature as H2. Okay, so the molar mass of a molecule of hydrogen is 1 times 2 because there are 2 H atoms in a molecule. Carbon exists as carbon, nitrogen exists in nature as N2, nitrogen gas. So the molar mass of 1 molecule of nitrogen is the number of atoms multiplied by the molar mass of 1 atom, which is 14, and so on. For example, phosphorus. Phosphorus can be solid or gas. The solid phosphorus exists as 1p atom. Okay, and the molar mass of 1 molecule of phosphorus solid is 31 gram per mole. It's only 1 atom. But when phosphorus is a gas, it becomes B4, 4 phosphorus atoms. Okay, so the molar mass of a molecule of phosphorus gas is 31 times 4, which is 124 gram per mole. Sulfur is another example, which exists in 2 states, solid or gas. Solid phosphorus exists. It doesn't form a molecule, okay? So its molar mass is 32, while sulfur gas exists as S8, a molecule of 8 sulfur atoms linked together. So the molar mass of sulfur gas is 32 times 8 because there are 8 sulfur atoms. Chlorine exists as Cl2, same idea. Okay? How to calculate the molar mass and the and the number of moles. If you are given the molar mass and you need to calculate the number of mole from this mass, or you are given the number of moles and you need to calculate how many grams of these moles. You can simply use this triangle. If you need to calculate the number of moles in a certain amount of substance, you will divide the mass by the molar mass. Okay? If you need to calculate the mass, so you will multiply the number of moles by the molar mass. For example, if you need to know the number of moles in 20 grams of chlorine. So you have the mass, this mass, okay? You have the mass, this is the mass. And you need to calculate the number of moles. How you calculate the number of moles? The number of moles will equal to the mass divided by the molar mass. And from the previous table, with the example, I show you how to calculate the molar mass. So the number of moles here, consider it as X, will equal to the mass, which is 20 grams, the mass that I have, times the molar mass. The molar mass of chlorine is the atomic mass multiplied by the number of atoms. The atomic mass of Cl, of one atom of Cl, is 35.5. And we have two Cl's, it will be 71. So the number of moles of 20 grams of Cl2 will be 20 over 71, and you can calculate it and get how many moles. It can be fraction. Okay? Another example. If you have 2 moles of nitrogen, of N2, of nitrogen gas, and you need to calculate the mass of these 2 moles. How can you calculate the mass? The mass of a substance from here equal to the number of moles times the molar mass. So the mass will equal to number of moles is 2 times the molar mass of N2 is the number of atoms multiplied by the number of the atomic mass. So the atomic mass of nitrogen is 14, and we have 2. So 2 times 14 will be 28. So the mass here is 56 grams. Okay? So again, if you put this triangle into in mind. So mass at the top and down, the base is divided into two, moles and molar mass. If you need to get the mass, you will multiply the moles by the molar mass. And the molar mass can easily be calculated from the atomic mass of the atom, which you can see in the periodic table. Okay? If you are asked about the mole, the number of moles, so the number of mole will be the mass divided by the molar mass. Okay? Let's see more examples. If you practice, you found it very easy. If you practice it, you will find it very easy. Try to calculate as much as you can. So some calculations. Carbon dioxide. Okay? The molar mass of carbon dioxide. The molecular mass of the carbon dioxide. The molecular mass is the sum of the masses of all the atoms of the molecules, and its unit is AMU. While the molar mass is the same calculation, but its unit is gram. The molar mass is the mass of 1 mole, okay? So to calculate the molar mass of carbon dioxide has 1 carbon and the 2 oxygens. Okay, and the atomic mass of carbon is 12. As we have 1, will be 1 multiplied by 12. And the atomic mass of oxygen is 16. So 2O will be 2 times 16. And when we add all these numbers together after multiplication, we'll get 44 grams. Again, molar mass of mole is its unit is gram. AMU is the mass, the unit for the mass for the atom, the molecular mass or the atomic mass. Okay, this is a mistake. H2. Oh, we calculated before. H2O, 2 H's and 1 oxygen. Then we multiply each number of atom by the atomic mass of each atom. And if we are calculating the molar mass, we will write at the end gram. If we are calculating the molecular or the atomic mass, we will use the atomic mass unit. HCl, 1 H and 1 Cl. So 1 and the atomic mass of H is 1 and Cl is 1 and the atomic mass of Cl is 35.5 and then the unit of molar mass is gram. So H1 mole of HCl has 36.5 grams HCl. HNO3. We have 1 N, 1 H, and 1 N, and the 3 O's. Okay, so we multiply the number of atoms of every atom, of every element, by the atomic mass of this atom, added to the molar mass of the second atom, added to the molar mass of the third atom. And so, since we have 3 oxygens, we will multiply the atomic mass of oxygen by 3, and you will get the result when you calculate it in grams. H2SO4, the same. So we have two H's. HS has 1 atomic mass, 1 sulfur, 4 oxygen. We have several examples. Okay, let's have this one. CuSO4 0.5 H2O, hydrated copper sulfate. Okay, so here let's see what are the atoms that we have and how many of each atom. We have copper, we have sulfur, we have oxygen, and hydrogen. We have one copper, okay, one sulfur, and for the O, we have 4 oxygen here, and here we have 1 times 5. So we have 5 oxygens here. Okay. As you remember, when the number is outside the molecule, so this number will be multiplied by all the atoms of the mate. So we have 5 oxygen from H2 here and 4 oxygen. So we have at the end 9 oxygens. And how many H's? 5 times 2, H2, okay, times the 5 molecules. So it will be 10 oxygens. So to calculate that, one copper times the atomic mass of the copper, which is it is given 63.5. Okay, plus 1 sulfur. Okay, which is 1 times sulfur atomic mass of sulfur 32 plus 9 oxygen. So 9 times H oxygen is 16, the atomic mass, plus 10 hydrogen, 10 atoms of hydrogen. 10 times the hydrogen is 1. So we can calculate all of these, and then we will get that mass in grams. Okay. You can do the same for ethanol. Ethanol C2H5OH. So we have 2 carbons, 2 H5, 6 hydrogens, and 1 oxygen. So my recommendation is you to get the periodic table beside you and find if you find any molecule or compound in front of your eyes when you go through the chemistry book, you can take this molecule and calculate the molar mass. So this is 2 because if they are 2 moles, now we calculate the masses from the moles. All what we did is calculating 1 mole of the substance. So if we have more than 1 mole, in that case, we will calculate the same masses for 1 mole and then multiply it by the number of moles. So I want you to take a screenshot of this and try to solve these. Okay, solve them yourself and remember that sometimes you have one mole and other times you have more than one mole. Okay, so solve it yourself and write down the comments down below. Okay, don't neglect because it's very important. This chapter is depending on the calculation, so we will need this calculation for everything in this chapter. Take a screenshot and calculate, okay, the molar masses. So this is another homework, but it's a challenging because I gave you the name of the compound. So this exercise will bind the um, the naming of the molecule with the mole because you will need to expect the symbol before you calculate. Natural gas, for example, is N2. Ozone is O3. O3. Ozone is O3. Ozone is O3. Phosphorus vapor, you will find it in the previous table, the table I gave you at the beginning of the video, which is phosphorus gas. And then everyone, you will need to write the formula first, the chemical formula, and then calculate the molar mass depending on the chemical formula. So this homework link the chemical formula together with the moles so you can practice and memorize what we have done before. If you are not able to get any of these, any sample of these, just you can make a small search or Google it, you can find it. So this is a summary of the triangles that I gave you before to calculate the number of moles from the mass or calculate the mass from the number of moles. Okay, so the number of moles equal to the mass in gram divided by the mass of 1 mole of this substance. Mass of a substance equals the number of moles multiplied by the mass of 1 mole. Mass of 1 mole equal to the mass over the number of moles. Remember, this depends on the triangle I show you before. Here we have the number of moles. Here we have the mass. And here we have the molar mass. The molar mass is the mass of 1 mole. So if we need to know the molar mass, the mass of 1 mole, which is the molar mass, this, you will divide the mass of a substance over the number of moles. Mass over the number of moles. Okay? If we need to calculate the mass of substance, we need to calculate this, the mass. So it will be the number of moles, the number of moles times the mass of 1 mole or the molar mass, and so on. So it's easy to write this, to draw this triangle to remember how to calculate any from any. So now we have the opposite. We have the mass, and we need to calculate the number of moles. Okay. So 19 grams of nitrogen gas. 19 grams of nitrogen gas. So 19 grams of N2. How can we calculate it? Remember, we can remember by the triangle. Here we have the moles. Here we have the mass. Have the molar mass of the mass of 1 mole. Okay, so we have the mass and we need to calculate the number of moles. We need to calculate the number of moles. So the number of moles is mass over molar mass. Okay, equal. So the number of moles equal to the mass, which is 19. Divided by the molar mass of nitrogen. So nitrogen, the atomic mass of nitrogen is 14. So the molar mass is 2 because we have 2 nitrogens times 14, which is 28. Make this simple calculation. Okay, and you will get how many moles. So it will be a fraction. Okay. 20 grams of ozone. Ozone is O3. Okay. So O3. How many moles of O3 in 20 grams? So we will calculate it, mass over the molar mass from the triangle. So the mass is 20. And the molar mass is, that oxygen is 16. So the molar mass is 16 times 3, which is 48. Oh, I divide both by 2. So you can divide it and write how many moles. Okay, will be a fraction too. So first you will need also to get the molecular formula of H1 before you calculate. And then calculate the mass, the number of moles from the mass. Okay, try to do that. If something is difficult, like the phosphoric acid, for example, you can Google it to find out the molecular formula of phosphoric acid. Solid phosphorus is just B, phosphorus. If you remember, solid phosphorus is B and gas phosphorus is B4. Okay. Try to solve it and write it down in the comments down below. Okay, remember this is 503 grams of water vapor. And this will help you to practice related calculations related to the moles and the molar mass. Okay, this is very, very important. Thank you guys. See you See you in the next video. Bye bye.